Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 60 in physics series, where we are discussing each and every chapter with previous year questions, and every week we are also conducting free of cost KPL, KCET Premier League, where we are giving you a question paper that you have to solve during the day, and at night we will be back with the solution. So if you want to join that exam brigade and want to improve your score for KCET 2025, then first of all you have to join our WhatsApp group. The link is given in the description, so don't forget to click on that link and join our WhatsApp group. Every Sunday we will be back with a fresh question paper, and to test your knowledge throughout whatever we have done in that week, we will be giving you fresh question paper. This week's question paper is based on electromagnetic induction and AC. So AC and electromagnetic induction we will be taking this week. So if you are wondering, last week we have completed the part related to moving charges and magnetism, and then magnetism and matter chapter. This week we are going to be giving you a question paper based on AC and electromagnetic induction. So this is going to be the chapter that we have completed yesterday. It was very small chapter, electromagnetic waves. So next week we will be giving you ray optics and wave optics combined together, okay, along with electromagnetic wave. So that three chapters combined will be taken care next week, right? But we have to continue. Every day we are posting one video, one concept videos or previous year questions video. So now today I will be starting with ray optics and optical instruments. So let's look into this chapter, what all we are going to study today. Today we will start with laws of reflection. This will be a very small video, as we are going to be focused more on AC and electromagnetic induction. That's why I will be keeping this short today, and tomorrow I will be keeping these two videos as short as possible. Then from next week we will be doing the most difficult concepts from this chapter. This chapter will going to be at least 3 parts. I will try to keep it at 3 parts, but maybe it may go to 4 part as well. So today what we are going to discuss, we are going to discuss laws of reflection, then we will discuss spherical mirrors, then we will discuss sign convention, equations of lenses obviously, then image formation and magnification. These are all we are going to discuss today, and a lot of problems also we are going to solve. So if you are wondering what should I do, you just take your pen, take your notebook, take your pen and sit through this video. It will be very, very useful. This is a very important chapter. A lot of questions comes from this chapter. So if you have watched our strategy video, there I have discussed which chapters are important. This is one of the most important chapters. So let's look into the concept first. So first we will start with the laws of reflection. The angle of reflection is equal to angle of incidence. Very common law. What is angle of incidence? If you forgot, angle of incidence is this is called angle of incidence. Okay, so first of all, this is the incident ray, this is the reflected ray, this is the reflecting surface, sometimes also called mirrors. Generally we observe reflection on mirrors. It can be any surface, okay, it does not necessarily to be mirror, okay, it can be any surface, and this is the point of reflection, okay, this is the point of reflection. So if you draw a perpendicular on the surface at this point, okay, then this is called a normal. Okay, normal has nothing to do with normal, abnormal, like that. Okay, normal means perpendicular. I hope you are familiar with this term. Okay, in mathematics also we use the term normal. Normal means perpendicular, okay, but it is used for a surface. Perpendicular is when a line is perpendicular to another line, okay, but when a surface is perpendicular to a plane, in that case generally we use the term normal. Okay, normal is actually quite normal. This is the term usage of this term is very, very normal. So what we do, we draw a perpendicular on the point of intersection, and the angle made by this incident ray with the normal is incident angle. Okay, so this angle say is theta I, and if this angle is theta r, then first law of reflection states that theta I equals to theta r. Right, you remember this law, very simple law. Also sometimes this angle is called grazing angle, the angle with which it makes with the angle mirror, this is sometimes called grazing angle. So you should be careful. Okay, this is not angle of incidence. Okay, some students who skipped the part when it was being taught in your class 10th and now they have almost forgotten what was incident angle, which angle was incident angle. So for them you should remember that angle of incidence is always is measured always with the normal, okay, not with respect to mirror. So be careful. Now let's look into the second law. Second law is also very common. Incident ray, reflected ray, and the normal drawn on the reflecting surface at the point of incidence lie on the same plane. So if you construct one plane okay, that plane will have incident ray, reflected ray as well as the normal. Okay, so you might think that why this is important, because three lines are there, right? Three lines are there, so you can construct n number of planes, right? N number of planes, because to construct one line you need 2 points, right? So let's break it down to our 2D convention where we use, suppose 2 points are there, right? So 2 points are there, I can only draw one single line, right? But if there is a third point, I can draw multiple number of lines, right? Like this. So there are different lines I can draw. But if they are collinear, if I say 3 points are collinear, so 2 points are not collinear. Remember that 2 points, if you are drawing a line, 2 points will have only one line. But when we say 3 points, there is a possibility of drawing 3 lines, right? So to specify that this third point is also located on that same line, you have to mention that they are collinear, right? Collinear. So third point is on this line, then we say they are collinear, right? So A, B, C, 3 points A, B, C, they are collinear. But in case of planes, when we are talking about planes, now we have lines. Okay, if we have only 2 lines, I can construct only one plane. Okay, if there are only 2 lines, I can construct one plane. So in case of 2 dimension, we need points, 2 points to construct one line. In case of 3 dimension, 2 lines is required to draw one plane. Now if there is a third line, I can construct again 3 planes, right? One plane like this, another plane passing through these 2 points, right? So I can construct 3 planes. But if I can draw 3 planes, unless and until they are coplanar, if these 3 lines are coplanar, okay, then I can draw only one plane. So you have to mention that these 3 lines are coplanar, or you have to prove that these 3 lines are coplanar. So in this case, these 3 lines are basically coplanar. That is what the meaning of this second law. Okay, so we have not dealt this concept in this detail, that's why I have chosen to focus only on reflection today. I am going to discuss refraction in tomorrow's class, and then lenses and prism in later on. So let's look into the simple problem. A ray of light is incident on a plane mirror at an angle of incidence 30 degrees. The deviation in the ray produced by the mirror. So what is the meaning of deviation? Let us understand that. Suppose I have a ray. A ray is passing like this. Okay, if nothing happens to this ray, if there is nothing present in between its path, it will continue to move along this line, right? It will continue to move along this line. Right? Now if you place a mirror in its path, if you place a simple plane mirror in its path, then what will happen? It will no longer continue to move in this direction. It will be reflected in some direction, right? It will be reflected according to the law of reflection, we know that. Okay, then if there was no mirror, what would have been the path? This would have been the path. And after the mirror is placed, what is the new path? This is the new path. So the angle between original path and the final path is called angle of deviation. So it is generally denoted by delta, right? This is called angle of deviation, and this is true for all types of rays. No matter reflection, it is true for refraction, it is true for any other properties, okay, scattering also. So deviation means how much it deviates from its original path. So for example, you started watching this video and suddenly you decide, sir is talking too much boring, I will go and watch some reels, okay, I will watch some entertaining videos, some songs, right? So what it happened, you deviated from your study course, you deviated from your lesson. So that is something we called is deviation. And the angle by which you deviate, suppose you deviate from studying from physics to mathematics, or from studying physics to chemistry or biology, then the deviation is okay, well, it's less deviation, you are still studying. But if you deviate from watching physics to watch some songs, then that is a complete deviation, right? So angle of deviation is this angle, and for if the angle of incidence say I, then angle of deviation is given by 180 degree minus 2I. Okay, now this angle is I, this angle is I, and total angle is 180 degrees, so it is 180 degree minus 2I. So here the angle of incidence is given 30 degrees. So what is the angle of deviation? 180 degrees minus 2 times 30 degrees, right? So it is 180 degrees minus 60 degrees, that is 120 degrees. So 120 degree is the angle of deviation. So correct answer is option C. Simple problem. If you have forgotten this formula, you now need to remember it, because based on this question might come, very simple question, because you remember that KCET question paper is not super hard. Okay, it's somewhat easy, somewhat difficult, and somewhat mixed. So you have to be careful. Sometimes easy questions appear to be difficult because you have forgotten how you can calculate. You can remember this formula like this, or you can derive the formula the way, whatever way you like. But if you know the concept, you can answer it, right? Now let's move on. Now we are talking about spherical mirrors. Okay, in spherical mirrors, what is a spherical mirror? Spherical mirror is a part of a sphere. As the name suggests, spherical comes from the term sphere, right? Sphere is a three-dimensional of circle, three-dimension of a circle, right? So sphere is like this, and if you rotate it, it is a circle. If you rotate it in a three-dimensional space, it becomes a spherical surface, like a ball, right? So what happens is, in this case, one side of the sphere, so suppose this is the outer surface, okay, and if you silver the inner part of the surface, you have silvered the inner part, okay. So in that case, what happens, if this part, generally silvered part is denoted like this. If you denote this, this is the silvered surface, okay, and light rays coming from this side reflects, okay, then this is a, what is the type of mirror? This is a convex mirror, okay, this is a convex mirror. Okay, so this is a convex mirror, and this is the reflecting surface. So here they have mentioned surface. So basically this is the reflecting surface. Inner wall is silvered. Okay, now similarly, if you have silvered the this side of the sphere, okay, basically what they have done, they have taken the sphere, they have cut it into two halves. Okay, they have cut it into two halves. Okay, one half they have silvered from inside, another half they have silvered from outside. Okay, so they cut it, then they have silvered from opposite sides. Now we will get two different types of mirror. Okay, this surface is, this is a concave mirror. Okay, and many students often struggle to remember concave and convex, and they confuse between convex and concave. So concave, I can make sure that you remember. Concave means concave with a term called cave. If you remember cave, right? So what is the meaning of cave? Cave is something which there is a hole in the mountain, you go inside, right? So you go inside. So basically you can say that whenever there is a curvature inward, when the curve is inside, that you have to move in, then you call it concave. So if you remember this, then it will be easier for you to remember. Concave means when curve is inward and you are going in. So basically you can consider this to be a door of the cave. So this has some curve, so you have to walk inside it. So that is why it is called concave. Convex means it is vexed outward, okay, vexed outward, that's why it is called convex, okay. So concave is you are going in, so it's like a door and you are going inside, so that's why it is called concave. And convex is it is vexed outward, that's why it is called convex, okay. Now sign convention, very very important, and this sign convention is true not only for mirrors. We will be using the same sign convention for lenses later on also. So you have to remember the sign convention, and if you are preparing for your PU board exam, sign convention, they often ask what is sign convention, draw a diagram, explain with the diagram. So 2 to 3 marks question generally comes from this concept as well, okay. I will not going to give you the notes for PU, but I will explain what is sign convention, how you can remember it. So if you remember in your previous class, you have studied x and y axis, right? So this was y dash, right, while drawing diagrams, right? This is x dash. Now what is the meaning of x? That means this is the positive side, right? This is the positive side. Similarly, this is the positive side, this is the negative side, and this is negative, right? Similarly, the same thing is applied in our lens or mirrors, okay. Previously there was a lot of different kind of sign convention, it was very very confusing. So that's why new Cartesian sign convention is applied. Cartesian is the coordinate system that we use, coordinate system x comma y, that is the coordinate system that we use, right? So that is that's called Cartesian coordinate system. And we are using new Cartesian coordinate system where everything is according to the geometry, everything is according to the coordinate system. So we assume this point, this is called pole of the mirror, pole, okay, pole, okay, sometimes center of the mirror, whatever you can call. This is a point that is considered as origin, 0, 0. So this pole is basically your origin, okay. Some books mark it as P, some books mark it as O, okay, and that is fine. This point, the center of the mirror, which is and this axis is called principal axis, right? This is called principal axis. Okay, this is called principal axis, and the thing is this principal axis is passing through the pole, passing through the focus, okay. I hope you know the focus, what is focus. I will going to be discussing that in a while, in a short while, but first you should remember that whenever we are measuring anything on the right hand side of this pole, anything on the right hand side of the x-axis, that is positive x-axis, so this is positive. Anything upwards is positive, anything on the left hand side is negative, anything downside is negative, right? These are the basic things that you need to remember. Now generally speaking, most books and most commonly we place the object on our left hand side. Mirror or lens or any thing that is being used in the center, okay, and light travels from left to right, okay. So this is our object, this is our object, okay, and light is traveling in this side, right? So in every case object distance is denoted by symbol small u, okay. Or every case object distance is negative, So whenever you start solving one question, don't forget to put the object distance as value negative, okay. We'll see the equations as well. So object distance is always negative, right? Object distance is always negative. Image distance can be negative, can be positive. If the image is positive, then it is on the right hand side, and if the image is negative, then it is on the left hand side. Now based on if it is mirror or if it is lens, okay, on right hand side it can be real image, it can be virtual image. Now you should also remember that in every case, whenever there is a real image, okay, real image means what? Real image means that you can project on a screen, right? So for example, when you went to a movie theater, you are watching a movie, that movie is actually a real image of the recorded scenes, right? It was recorded some time back using a camera, and then it is projected on the screen and you are watching the real image. So that is a real image, okay? Whereas virtual image is when you see yourself in the mirror, okay? So when you see yourself in the mirror, you cannot touch yourself, so that's why it is a virtual image. But if there is a screen, you can go and you can touch that image, you can project it, you can focus it or defocus it, so that's why it is called a real image. And whatever is forming behind the mirror, especially for mirrors, if it is forming behind the mirror, then we consider it as a virtual image, because there is no virtual space actually behind the mirror, right? Behind the mirror there is a wall, so you cannot go behind the wall and you can touch it, right? So that's the logic, okay? So now so object distance is always negative. For real image, the height is always negative, okay? And for virtual image, the height is always positive. So height is, that means erect image. Erect, when the image is erect, then it is a virtual image. If the image is inverted, then it is a virtual image, okay? Real image. So these are the basic things that you need to remember. Now let's move on without complicating anything. So now we are talking about equation of mirror. So if you remember equation of mirror, it is slightly different than equation of lenses, okay? 1 by V plus, in case of lenses the equation is slightly different. I will tell that when we are talking about lenses. So 1 by V plus 1 by U equals to 1 by F, or it is written as 2 by R. So what is F? F is the focal length. Let me explain all the symbols. Suppose in front of a convex lens I have placed one object, okay? The distance, this distance is U, okay? And suppose I am observing one image here, okay? So this is this distance is V, okay? Where it bisects here, this is F, and the double of this distance somewhere, this is C, okay? So now, because this is a sphere, right? This is a part of the sphere. Part of the sphere means you can consider in 2 dimensions, this is a circle. So each circle, what they will have? They will have a center. Circle will definitely have a center. So in case of spherical objects, and this is a part of the sphere, so that's why it is called center of curvature. Center of curvature. Center of curvature means if it was to be a circle, if it was to be a sphere, then the center, whatever would have been the center, that is the center of curvature. Now it is not a pure sphere, because if it is a pure sphere, then you would have not be able to see it, right, from inside. You have to be inside of the sphere. So that's why it is not called the center of the sphere, it is called center of curvature, okay, of the mirror. Center of curvature is the center where actual center of the spherical surface is located. So that distance is generally denoted by R. Now we know that radius is denoted by R. So R is basically radius of curvature, or radius of the sphere, also called radius of curvature, okay? So in case of part sphere, because it is not full sphere, not full part of the, it is a partly sphere, okay, because we have cut this part, right? So that's why we call it center of curvature and radius of curvature. Right? So the relationship, another relationship which is important is that basically F is equal, 2F equals to R. So radius of curvature is twice that of the focus. Now what is the focus? Focus is the point where all the rays falling on the mirror parallel to the principal axis, okay, they either focus or Focus means obviously they converge at a point or they appear to come from a single point. So this only happens when parallel rays are falling on a mirror. When parallel rays fall on a mirror, either they converge, like they meet at a point, okay, or they appear to come from a point. So that is what is called focus. So for example, you all are having a weekend party and you all went to your friend's house, okay, to watch some movies, then that is called the focal point, okay. So then you have all meted there, then that is the focal point. Or you lied to your mother, okay, and you said we were at his house. Everyone said we were at his house. So it was actually appeared to be his house. So that is a focus point, focal length, okay. So focal length, the distance between this and the pole is called focal length. So distance of the focus from the pole is called focal length, okay. And radius of curvature obviously the radius of the spherical surface, right. So this is the relationship that also you need to remember, and for PU students this derivation is also important, okay. Now this formula is valid for all situations, for all spherical mirrors, for all positions of the object. You must use, very important, you must use the new Cartesian sign convention, where while substituting the numerical values of u, v, f and r in the mirror formula for solving this problem. So you have to use the sign convention if you are applying this equation to solve numerical problems, okay. Now let's look into a numerical problem. A point object is moving uniformly towards the pole of a concave mirror of focal length 25 centimeter. So focal length is given, focal length f is given 25 centimeter, okay, along its axis as shown below. So it is moving along the axis as shown below. Velocity of the object is given by 1 meter per second, right. Now the speed of the object is 1 meter per second. At t equals to 0, the distance of the object from the mirror is 50 centimeter. So at time t is equal to 0, this distance is given 50 centimeter, okay. The average velocity of the image formed by the mirror between time t is equal to 0 and t equals to 0.25 is, t is equal to 0.25 is, what is the average speed of this image, okay. So now first of all you should remember this is actually equals to r, right. So the image object is at u is equal to minus 50 centimeter. So if you see, I have used the symbol here, and focal length, since it's a concave mirror has a focus here, so focal length will also be negative. So focal length is also minus 25 centimeter. Now initially what is the position of the image? Now you can solve that using mirror equation, fine, but we know that when the object is placed at the distance 2f, if you see here u is actually 2f, right. So twice the focal length, that is at the radius of curvature. So when the object is placed at radius of curvature, the image is also formed at radius of curvature for a concave mirror. So this is a trick that you have to remember. So if you place the object here, initially the image will be also be formed here, okay. So this is the initial position, this is the initial position of the object and image. So basically image and object both are starting at the same position. Now they have said that the object is moving with a 1 millimeter per second towards the mirror, right, towards the mirror. So after 0.25 second, what will be the after 2.5, suppose the object moved here. At this point, what is the object distance u? So let us find the object distance u for this case. So we can find this distance and then subtract it from 50 centimeter. Then we will get the object distance. So first we have to find this distance. So this distance is, suppose that distance is d. So d is vt, right? U is equal to VT, S is equal to VT. VT, V is 1 meter per second, that is, let me write 1 meter as 100 centimeter, that will be easier. So 100 centimeter. So this, in most cases while solving we generally convert from centimeter to meter, but in this case for meter equations, meter cases, generally we do it opposite. So we convert from meter to centimeter. So 100 centimeter in 0.25 second. Okay, so the distance is 25 centimeter. So the object will be at the focus. Okay, so the object will be exactly at the focus after 0.25 second. So the object will be exactly at focus at 0.25 second. Now, if the object is located at focus, then where the image is be formed? If the object is located at focus, then the image will be formed at infinity. We will see that in a while, all the tables, okay, to remember that. So if the object is at focus, the image will be formed at infinity, okay, and they will converge at infinity. So the initial position was 50, the final position is infinity now for image. The image started at 50 centimeter, now the image is located at infinity. Then what is the speed? The speed will be obviously infinity. So without even doing any mathematics, without even using the mirror formula, we have solved it, that the speed of the image will be infinite, because it started at 50 and suddenly in 0.25 second it reaches infinity. So as soon as the infinity is involved, everything becomes infinity. So the speed of the image will be infinity. Okay, simple. Now, image formation by convex mirror. Let us look into the convex mirror first. So what are all the positions? There are only two positions. Okay, first position is object is at infinity. So if you keep the object at infinity, for example, if you are focusing a distant star, okay, or a very far object, generally what is the concept of infinity? Let us talk about that first. Okay, when we are talking infinity, any object which is quite far from the mirror generally considered infinity, and which is whenever the distance is very high compared to the focal length of the mirror, generally we call that as infinity. For example, if the focal length of the mirror is 10 centimeter, then for this even 5 meters or 2 meters will be considered as infinity, because that is very far. Okay, so for a mirror, if it is 10 times or 20 times, even 100 centimeter, that is 1 meter object, can be considered as infinity. Okay, so if the focal length, any distance which is comparatively higher than the focal length, we call that distance as infinity. Very important. Okay, but theoretical infinity is farthest object, for example the star. Okay, but if you want to focus the star using a mirror, you will not be able to do it. Small mirrors will not be able to focus it, because it will be very difficult. Very small amount of ray is coming. But if you are using a very large mirror, that like the it is being done in different observatory. Okay, there is a very large mirror located in Aries. Okay, they have a mirror, they focus the light from distant stars and observe the images. Okay, Aryabhatta Institute of Aryabhatta Institute of Astronomy and Physics, so you can check there. Okay, now position of the image will be at the focus. Okay, and behind the lens. So if the object is located very far, the image will be formed at the focus, and it will be behind the lens, behind the not lens, behind the mirror. Okay, and it is highly diminished and point sized. Okay, the image will be very small and point sized. It will be virtual and erect. So image will be virtual and erect. Okay, now similarly, when the object is placed between infinity and the pole, okay, of the mirror, between infinity and pole, any point of the mirror, then it will be formed between P and F, that is for pole and the focal length. Okay, and it will still be behind the mirror. Okay, it will still be behind the mirror. Again, the image is diminished. Again, the image will be diminished, and virtual and erect. So convex mirror will always form virtual and erect images. Convex mirror will always form virtual and erect images. Now let's look into concave mirror. Image formation by concave mirror. So here it is very interesting, a lot of things are there. So position of the object at infinity, okay, it will form, image will be formed at the focus. Okay, so if the object is at infinity, the image will be formed at focus as discussed. Highly diminished point size, in this case also it is highly diminished point size, and the image will be real and inverted. So it will be very small and inverted, right? Next is beyond C. Beyond C means beyond the curvature, radius of curvature. If it is beyond radius of curvature, that is between infinity and radius of curvature, any high distances, then the image will be formed between C and F. Okay, the image will be diminished, that is small in size, real and inverted. Okay, if the image is located exactly at the center of curvature, then the image will be formed exactly at center of curvature. That logic we used in our previous problem. Okay, the size will be same. Okay, and real and inverted image will be formed. Okay, between C and F, if the object is now coming closer to the mirror, okay, the image will be now going back. So when you are bringing the object forward, the image is going slowly outside. Okay, so initially you started with the focal length. As you are going towards the mirror, suppose you started at infinity. Okay, you started at infinity and you are going towards the mirror. So when you are at infinity, your image formed at the focal length. Now you are moving towards the mirror. Okay, when you are between infinity and C, okay, your image is now being formed between F and C. Okay, now as you directly reach to C, now your image is exactly formed at C. Now as you are going towards the mirror, your image is now going backward. So when you are moving forward, your image is moving in the opposite direction. Okay, now the image will be enlarged, real and inverted, right? Now exactly at F, that was the point of our last solution. Okay, exactly at F, image will be formed at infinity. Okay, it will be very highly enlarged, very high. Okay, and it will also be real and inverted. Okay, now between P and F, when you are now you have crossed even F. Okay, now you are located at between P and F. Now what will happen? You have already reached infinity. Your image is already at infinite. So it has to come back from the behind. It will come back from behind. Now it will be behind the mirror. Very interesting, right? So you are slowly moving closer to the mirror. So at focus, your image is exactly located at infinity. Now there is no space left behind. So it has to go behind the mirror and come back towards you. Okay, the image will be enlarged and virtual and erect. So in this case, a concave lens is forming virtual and erect image. So all other cases, it is forming real and inverted image. Okay, so concave lens can form real image and virtual image, but convex lens can form only virtual image. So let's look into one question from your previous years. For a point object, which of the following always produces a virtual image? So this is a previous year question. This simple. If you have studied this, you can answer that, right? A plano-convex lens, no. Plano-convex lens cannot produce a virtual image. It can produce virtual image, but it can produce real image also. Okay, always produce means it has to be either convex mirror or a concave lens. Now concave lens is not given here. We will discuss that when we are studying lenses. So convex lens, plano-convex or biconvex or concave mirror, they all can produce real images as well. So only always produce will be convex mirror. Okay, so convex mirror will be the answer. Now let's look into the magnification formula. In case of magnification for mirrors, it is given by minus V by U. What is the meaning of magnification? So you have seen magnifying glass, even though that is a lens. If you put the magnifying glass closer to small letters, it becomes big, right? So magnification means how big the final image is. So that is what is called magnification. So this negative sign is important for mirrors. For lenses, the negative sign is not there. We will discuss that later on. Okay, but you should remember that this also includes the sign. Okay, here you have to use the sign for U and sign for V. So if u and v both are positive, that means the sign is negative, that means image is inverted. Negative sign represents if the actual image is inverted, then the negative sign represents the image is inverted. But if actual sign is positive, that means image is upright. So for real images, magnification is negative. For virtual images, magnification is positive. That also a very important point. Okay, now let's see one problem. A person wants a real image of his own 3 times enlarged. Where should he stand in front of the concave mirror of radius of curvature 30 centimeters? So radius of curvature is given 30 centimeter. Okay, so from there you can use the focal length as well. Focal length is 15 centimeter, or you can use direct 1 by v plus 1 by u is equal to 2 by r. That is also fine. Okay, now the magnification is given 3 times. Okay, that is equals to minus v by u. Okay, so 3u equals to minus v, or v equals to minus 3u. Okay, they want a real image. So real image means they want real image. So that's very important. Real image means magnification has to be negative. So what we have to do, magnification we have to take as negative. As I said, for real images magnification is negative. For virtual images magnification is positive, because real image means it is inverted, virtual image means it is upright. So we can cancel this negative sign. So this is very you be very careful. Okay, if you are not using proper sign, in this case, okay, you might use 3 is equal to u by v, v by u, and you can solve it. But if they ask virtual image, okay, or in front of the, they want to see mirror in behind the mirror, then you will be very sad that your answer does not match with the given options. So be careful. Okay, now we know that 1 by v plus 1 by u is equal to 1 by f. Okay, so what is 1 by v? V is given by 3u. So instead of writing v, I will write 3u. Okay, plus 1 by u equals to 1 by f. Okay, so let's solve. 1 by 3u and u, the common LCM is u, 3u. Okay, so here it is 3u, that means it will be 1 plus, so 3u means here has to be 3, right, equals to 1 by 15. F is given. Okay, and for concave lens, this is negative, concave mirror, sorry, it will be negative. So 4 by 3 u equals to minus 1 by 15. So cross multiply it. 4 times 15 equals to minus 3u, or 3u equals to minus 60, or u equals to minus 20 centimeter. Okay, so the answer is 20 centimeter. The image should be put at a distance 20 centimeter from the mirror. Okay, so this is the correct answer. If you are using sign convention, use it properly. You don't know when there will be a trap. If you are not using the sign convention, you might fall into the trap and your answer may be incorrect. Okay, now let's look into the homework problem. This is not second, this is first homework problem. Okay, my mistake. This is a homework problem. You can pause the video here. You can see the question, solve it, mention the answer in the comment below. Okay, if this is correct, I will mention your homework is correct. Okay, next homework question. This is 2. Okay, fine. Now again you can pause the video, read the question, answer the question in the comment below. I will reply to you. And if you are wondering where you can see all the videos, there is a playlist created exclusively for KCET physics content. You can go and bookmark this playlist, and anytime we are uploading a video, you can get that notification, and you can check that from your bookmark and study at your own pace, at your own time. And whenever you are studying, don't forget to mention that in the comment, and I will be back with a new video tomorrow. Before that, you have to join our WhatsApp group, and if you like our videos, don't forget to share with your friends and subscribe to our channel. Thank you. Till tomorrow.